figures. Today we're going to go over the area formulas for trapezoids, rhombi, and kites. So just as a refresher of what a trapezoid is, it is a quadrilateral quadrilateral meaning it has four sides with two parallel sides. Okay, so our parallel sides here are opposite each other. Okay, they're marked with those arrows. You have that one pair of parallel sides. Okay, the height is the perpendicular distance between the two bases. So our height is still this perpendicular piece. So to find our height, we have to look for that 90-degree angle created. So in the picture at the right, your height is the length right here. Okay, it's that perpendicular distance between your two parallel lines. Your two parallel lines are considered the bases of your trapezoid. Okay, so to find the area formula of a trapezoid, okay, our next statement says the area of a parallelogram is the product of the height and the sum of the two bases, base sub 1 and base sub 2. The area of one trapezoid is 1/2 the area of the parallelogram. So you can see at the left here you have this parallelogram, right? It's split into two different trapezoids. Okay, you have this base and this base. Okay, so adding those two bases together multiplied by the height would give you the area of that parallelogram. However, to get one trapezoid then, you just divide it by 2 because it's split into two trapezoids. So the area of a trapezoid is the height times base sub 1 plus base sub 2. So our two bases added together, then divided by 2. Okay, so our height, again, that perpendicular distance between those two parallel sides, multiplied by our two bases added together, again, those are your parallel sides, then divided by 2. Okay, so we're going to do some examples using that area formula. So number 1, the purse is in the shape of a trapezoid. How much material is needed to make the side of the purse showing? So again, first step, locate your height. Your height is the perpendicular distance. Okay, that's this dashed line right here. Okay, so the height is that perpendicular distance between your two bases. So my two bases would be this top line and this bottom line. Okay, so I have my two bases and my height. Okay, height is h. I'll say 28 centimeters is base sub 1 and 58 is base sub 2. Okay, so since I have measures for all three of those sides, I can just plug it into my area formula. Okay, so the area of the front side of this purse, our height is 30 times base sub 1 is 28 plus base sub 2 is 58, and that quantity is divided by 2. Okay, so 30 times that quantity added together, then divided by 2. And you do get an area of 1,290 centimeters squared. Okay, questions on number 1. All right, do number 2. It's a lot of windshield. Yep. Yep, it is. All right, so number 2, again, first locating the height. That's this perpendicular distance right here. Okay, then my bases have to be the parallel sides of that trapezoid. Okay, so I have my parallel sides of that trapezoid. So I do have all 3 of those lengths, so I can just use my area formula. So we take our height of 38, multiplied by our 2 bases added together, and then divided by 2. Okay, and you should have gotten an area of 2,983 inches squared. Okay, questions on 2? Thank you. All right, then number 3 says, what is the area of one earring that is in the shape of an isosceles trapezoid? Do you remember what an isosceles trapezoid is? What it means to be isosceles? You have 2 sides congruent, right? So in an isosceles trapezoid, your 2 legs are congruent. Okay, so that would be these 2 sides right here. Okay, those are your 2 legs. So that means this side is also 3. Well, in our picture, we're not given the height of this trapezoid. Okay, your height is not 3 because it's not perpendicular between those 2 bases. So if I draw in a height here, okay, where it's perpendicular, I'm going to draw in another height right here. Okay, what does that make this length between those 2 points of intersection? 2, right? So what do you think each of these lengths would have to be? 1, because it's isosceles, so it splits it in half. So if this section is 2 and these 2 pieces are 1, I created this right triangle off to the left here and at the right, okay, and I can now find that height. Okay, so I have a right triangle with 3 centimeters and 1 centimeter. So I'm trying to find one of the legs of that right triangle. So using the Pythagorean theorem, I would have 1 squared plus h squared is equal to 3 squared, since 3 is the hypotenuse of that small right triangle created. So I have 1 plus h squared equals 9. Subtract 1 from both sides. H squared is equal to 8. Take the square root of both sides. And I'm just going to round to a decimal here of 2.8. Okay, so now I found the height of this trapezoid. I was given both base lengths, so now I can find the area of that trapezoid. Okay, so we'll take our height of 2.8, multiply by our 2 bases added together, so 2 plus 4, and then divide by 2. Now I got 8.4 centimeters squared. Okay, questions on the area of a trapezoid? Using the formula, anything like that? All right, then if we go to the next page here, or on the back, we have a rhombus and a kite. So again, just a refresher of what each of these are. A rhombus is a parallelogram with all four sides congruent. Okay, so a rhombus has all four sides congruent and is a parallelogram. So with our pictures off to the right here, this one is a rhombus. Okay, all four sides are marked as congruent and your opposite sides are parallel. Okay, a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. Okay, so we have sides next to each other that are congruent. So right here, this is your kite. You have this pair of sides congruent to each other and this pair of sides congruent to each other. Okay, so this one is a kite. Now your area formula for both a rhombus and a kite is the same. Okay, that area formula is 1/2 d sub 1 times d sub 2. Okay, or you can think of it as d sub 1 times d sub 2 divided by 2. Okay, where d sub 1 and d sub 2 are the diagonals. Okay, so you're looking for the diagonal lengths in these ones. So looking at this first figure here, this is a rhombus. Okay, some properties of a rhombus, if you forgot, your diagonals are perpendicular. So they form 90-degree angles. Okay, diagonals are perpendicular. Since it is a parallelogram, your diagonals also bisect each other. So that means the pieces of your diagonal are congruent for each diagonal. Okay, so if you have one piece, you'd have the other piece of that entire diagonal as well. Now in a kite, some properties. Again, your diagonals are perpendicular. Okay, and one of your diagonals does get bisected by the other. Okay, that has to be this one right here. So remember in a kite you had one pair of opposite congruent angles. Okay, that would be these two here. So you have one pair of congruent pieces of your diagonal as well. Okay, these two pieces are not congruent. So we are going to go through a couple examples here. So we want to find the area of each rhombus or kite. In 3A, this one is a rhombus. Okay. I have this piece of this diagonal as 6 millimeters and this piece as 7 millimeters. However, I do have those congruency symbols. So since this piece is 6 millimeters, this one is also 6 millimeters. And since this one is 7 millimeters, this one is 7 millimeters. Now using my area formula, I need the entire diagonal's length. Okay, so I need that entire length there. So I'd add those two together to get 12. And then the other diagonal, I need that entire length. So again, add your two pieces together. That would be 14. So now I have diagonal 1 and diagonal 2. Okay, so using my area formula, take diagonal 1, multiply it by diagonal 2, then divide that by 2. I got 84 millimeters squared. Questions on 3A? All right, do 3B. All right, so for 3B, you were already given the entire length of both of those diagonals. Okay, so you can just use your area formula right away. So diagonal 1 I labeled as 9, diagonal 2 I labeled as 16. Those can be interchangeable. You don't have to label them the same way I did. Multiply those together and divide by 2. And that would be 72 inches squared. Okay, questions before we do the last one? All right, so 3C, we want to find the area of the kite shown. Now, in this picture, this bolded line right here is the piece that's 6 inches, okay? This piece over here is 10 inches, and this one is 17 inches. And remember, we need to find each piece of the diagonals. However, since this is a kite, your diagonals are perpendicular. Okay, so they form 90-degree angles. Well, if I look at this darker right triangle right here, I have 2 sides of that right triangle. So I can find this third side here, okay, by using the Pythagorean theorem. Okay, so I would have 6 squared plus x squared is equal to 10 squared, since 10 is the hypotenuse of that right triangle. So I end up with 36 plus x squared is equal to 100. Subtract 36 from both sides of your equation. X squared equals 64. Take the square root. Okay, so that piece of that diagonal is going to be 8 inches. Now again, since this is a kite, you have 2 pieces of your diagonals that are congruent. I'll show you why. Since you have consecutive congruent sides, and this one is 10 inches, this one over here is also 10 inches, okay, and this piece is still 6 inches. So if you were to do the Pythagorean theorem again, using this right triangle formed, you'd get 8 again, okay. So this piece right here is also 8 inches. Now the only other piece I'm missing is this length right here, okay. So I'm going to label that one as Y. You can label it whatever you want. So now since I have this length of 8 and this length of 17, again this is a right triangle, so we can use the Pythagorean theorem one more time to find that remaining piece. 17 is your hypotenuse since it's opposite that 90-degree angle, so it is the C value in the Pythagorean theorem. So you would set this up as 8 squared, since we found that side, plus y squared is equal to 17 squared. Okay, 8 squared is 64. 17 squared is 289. Subtract 64 from both sides. Y squared will be equal to 225. Take the square root of both sides then, and y is equal to 15. Okay, so that remaining piece of that diagonal is 15 inches. So now I have each piece of the diagonals, so I can find the entire diagonal here. So this one, so add those two pieces together. That would be 16. Okay, same thing here. Add your two pieces together. I have 6 inches and 15 inches. So together that's 21. Okay, so I have diagonal 1 and diagonal 2. So now we can find the area using our formula from above. So multiply 16 times 21 and divide it by 2. Okay, and that would be 168 inches squared. Questions on how I did 3C, finding the area of that height.